everyone, I hope you're doing good. My name is Pranav Kule and I'm back with the second part of Algebraic Expressions and Identities on the behalf of Tutor Here. Now, previously we saw multiplications within monomials. Now let's look at multiplying a monomial with a binomial. Let's look at it with an example. Suppose we have to simplify x into x minus 3 plus 2 for x is equal to 1. And second example is 3y into 2y minus 7 minus 3y minus 4 minus 63 for y is equal to minus 2. Here for the first equation, what we have to do is we have to just simply open the bracket, and what it becomes is x square minus 3x plus 2. And for x is equal to 1, we just have to replace x by 1. Therefore, x square minus 3x plus 2 becomes 1 square minus 3 into 1 plus 2, which comes down to become 0. Similarly, in the second example, when we open the brackets, what we get is 6y square minus 21y minus 3y plus 12 minus 63. This becomes 6y square minus 24y minus 51. Now for y is equal to minus 2, this equation becomes 6 minus 2 square minus 24 into minus 2 minus 51, which is 6 into 4 plus 24 into 2 minus 51. This comes down to 21. This is how you multiply a monomial with a binomial. Let's try and do this. Subtract 3pq into p minus q from 2pq p plus q. Now here we have 3pq p minus q is equal to 3p square q minus 3pq square, and 2pq p plus q is 2p square q plus 2pq square. So as we learned in the previous video, we have to note the like terms in one column. Therefore, we get minus p square q plus 5pq square. Multiplying a binomial with a binomial. So suppose we have 3a plus 4b and 2a plus 3b. Now what if we multiply it? How are we going to approach it is, we have to split the brackets and multiply one binomial with the individual terms of the other binomial. So suppose let's split 3a and 4b. So how we are going to approach is 3a into 2a plus 3b plus, because there's a plus operator in between 3a and 4b, plus 4b into 2a plus 3b. What we have done here is we have splitted one binomial and multiplied each terms of that binomial with the whole of the another binomial. Therefore, in multiplication, we get 3a into 2a plus 3a into 3b plus 4b into 2a plus 4b into 3b, which comes down to 6a square plus 17ab plus 12b square. Now, what if we multiply binomial with a trinomial? Let's see how this works. Suppose we have to simplify a plus b into 2a minus 3b plus c minus 2a minus 3b into c. What we have to do is we have to take up the similar approach. What we have to do is we have to split one term, preferably binomial, because it's easier and quicker and it has lesser terms than trinomial. So here we have split a plus b as a into 2a minus 3b plus c plus b 2a minus 3b plus c, which comes down to 2a square minus 3ab plus ac plus 2ab minus 3b square plus bc. And hence, on simplifying further, we get 2a square minus ab minus 3b square plus bc plus ac. Now, for the second part, that is minus 2a minus 3b into c, what we have to do is we have to again split it further, like 2a square minus ab minus 3b square plus bc plus ac. This is what we got previously. And on multiplying c with the binomial, we get minus in bracket 2ac plus 3bc. Now on further simplifying it, the final answer here is 2a square minus 3b square minus ab plus 4bc minus ac. Here on further simplifying, And further simplifying, what I mean is we have to add or subtract the like terms and further simplify it. Like here, let me just see. Yeah, AC and minus 2AC. These are like terms. So what I've done is I've just added both the terms and what we get is minus AC. This just makes the equation look smaller and neater. Identities. We have total of 4 identities. A plus B the whole square is equal to A square plus 2AB plus B square. A minus B the whole square is A square minus 2AB plus B square. A plus B into A minus B is A square minus B square. And finally, x minus A into x minus B is x square plus A plus BX plus AB. I want you to pause the video and note this down and memorize these 4 identities. Now for A plus B the whole square, let's look at these identities using an example. Suppose we have 103 square. Now what normal people would do is just multiply 103 twice and we'll get the square, or maybe use a calculator. But there's a way quicker way to solve it. What we can do is we can write 103 square as 100 plus 3 the whole square, because 100 plus 3 comes out to 103. And here we can use A plus B the whole square formula, where 100 square plus 2 into 100 plus into 3 plus 3 square, which is 10,000 plus 600 plus 9, which is 10609. Isn't this a quicker way to solve it than finding the square of 103? Anyways, so A minus B the whole square. Suppose we have 49 square. Now 49 square can be written as 50 minus 1 the whole square, which is 50 square minus 2 into 50 into 1 plus 1 square, which is 2401. Now here, you can also solve it using 40 plus 9 the whole square. But it's a tedious job, don't you think? 50 minus 1 is a better way to approach it. So you have to look at the question and then you have to decide whether you have to use A plus B the whole square or A minus B the whole square. In both cases, you're going to get the right answer. A plus B, A minus B. Suppose we have 983 square minus 17 square. What we can do is, now A square minus B square is equal to A plus B and A minus B. We know that. Therefore, 983 plus 17 and 983 minus 17, which is 1000 into 966, which is 966000. Now, would you rather find the square and then subtract it, or isn't this the easier method? You think for yourself. And finally, x plus A and x plus B. Here we have 95 into 103. This can be again written as 100 minus 5 into 100 plus 3, where 100 is x. Therefore, as per the formula, we get 100 square plus minus 5 plus 3 into 100 plus minus 5 into 3, which is 10,000 minus 200 minus 15, which is 9785. These are just some kind of hacks and quicker way to approach maths. So thank you for watching this video. If you have any doubt, just ping me on the comment section and I'll answer it. Till then, thank you for watching.